Rocks and minerals. Time to warm up. We are not of same kind. We are of different types of rocks. Time to know. The whole earth is made of rocks and minerals. Inside the earth, there is a liquid core of molten rock, and on the outside, there is a hard crust. If you compare the earth to an egg, the shell on an egg is like the crust on the earth. The crust is made up of rocks and minerals. Much of the crust is covered with water, sand, soil, and ice. If you dig deep enough, you will find always hit rocks. Rocks. The rocks you see around you, the mountains, the canyons, and the riverbeds are all made of minerals. A rock is made up of 2 or more minerals. Think of a chocolate chip cookie as a rock. The cookie is made of flour, butter, sugar, and chocolate. The cookie is like a rock, and the flour, butter, sugar, and chocolate are like minerals. You need minerals to make rocks, but you don't need rocks to make minerals. All rocks are made of minerals. Minerals. A mineral is composed of the same substance throughout. If you were to cut a mineral sample, it would look the same throughout. There are about 3,000 different minerals in the world. Minerals are made of chemicals, either a single chemical or a combination of chemicals. There are 103 known chemical elements. Minerals are sorted into 8 groups. Igneous rocks. Igneous rocks are formed deep inside Earth's crust. Intrusive rocks, or at the surface, extrusive rocks. As molten rock, known as magma. Below the surface cools. The liquid material begins to solidify into minerals of differing sizes and compositions. Generally, the longer the cooling time, the larger the mineral crystals can grow. Trapped deep in the earth, magma is allowed to cool slowly. Examples of intrusive rocks are granite and gabbro. Granite is made up of 3 common minerals: quartz, mica, and feldspar, and when viewed from a distance appear tan, pinkish, or grey, depending on the concentrations and grain sizes of the 3 minerals. This rock is very widely used as a building material. Due to its abundance and strength, gabbro has a lower quartz content than granite and is therefore much darker. Liquid rock that reaches the surface cools very quickly. As a result of this immediate cooling, the crystals produced are extremely small. These tiny grained minerals tend to give these extrusive rocks a rather opaque, homogeneous color. All of the world's sea floors are produced in this manner of rapid cooling, and the dark gray, heavy rock produced is called basalt. Andesite, named after the Andes mountain in South America, is a cousin to basalt in that it is also volcanic in nature, but is lighter colored due to the decreased concentration of darker minerals. Types of igneous rocks. Granite. Granite is a coarse-grained igneous rock, often with a pink to reddish color. A large portion of the granite is made of small crystals of orthoclase feldspar, which give the rock the pink or reddish color. Other minerals present are quartz, usually grey, albite feldspar, white, and either white mica, muscovite, or black mica, biotite. The word granite means grain rock, whereas it crumbles into loose grains. Basalt. Basalt is a fine-grained igneous rock rich in iron that gives a black to brown color. Fluid lava flows, such as those in Hawaii, produce basalt. Basalt has a large number of gas bubble holes. It is called vesicular basalt. Or scoria. Basalt that has been exposed to air and water for a long time may oxidize to a red color. Pumice. Pumice is a volcanic glass filled with gas bubble holes, vesicles. It may be thought of as a glass foam. Because of the large number of holes, pumice is very light. Pumice is very lightweight. It will float on water. Pumice comes in many colors, but the most common color is gray. Granite, basalt, pumice. Sedimentary rocks. Sedimentary rock is one of the three main rock groups, along with igneous and metamorphic rocks, and is formed in four main ways: by the deposition of the weathered remains of other rocks, known as clastic sedimentary rocks; by the accumulation and the consolidation of sediments; by the deposition of the results of biogenic activity; and by precipitation from solution. Sedimentary rocks include common types such as chalk, limestone, sandstone, clay, and shale. Sedimentary rocks cover 75% of the Earth's surface. Four basic processes are involved in the formation of a clastic sedimentary rock: weathering, erosion, caused mainly by friction of waves; transportation, where the sediment is carried along by a current; deposition; and compaction, where the sediment is squashed together to form a rock of this kind. Sedimentary rocks are formed from overburden pressure as particles of sediment are deposited out of air, ice, or water flows carrying the particles in suspension. Types of sedimentary rocks. Shale. Shale is made of clay-sized particles or clay minerals that have compressed by the weight of overlying rocks. Generally, shale has the tendency to split into airily flat fragments. This property is known as fissility. Shales can be many colors, such as black, gray, brown, red, or gray, depending upon the presence of organic materials and iron oxides. Shales represent the accumulation of clay at the bottom of oceans or lakes. Shales are often a good source of fossils. Sandstone. Sandstone consists of sand grains that have been cemented together. Sandstones can range from coarse-grained to fine-grained. You should be able to distinguish the sand grains with the naked eye. Light-colored sandstones consisting mainly of rounded, well-sorted quartz grains are referred to as mature sandstones or quartz sandstones. Sandstones that contain angular grains of several different minerals are referred to as immature sandstones or grey walkers or grey wax. Sandstones contain feldspar grains are arkoses. Sandstones can be white, grey, pink, red, brown, or black. A fresh broken surface of sandstone has a gritty feel. Conglomerate. Conglomerate is made of rounded or semi-rounded rock fragments cemented together. The rounding of the fragments implies that the fragments were transported a substantial distance from their source and were abraded in contact with other moving fragments. The rounded fragments were probably deposited along a stream channel or a shoreline. Fragments within a conglomerate are pea-sized and larger. An older name for conglomerate is pudding stone. Limestone. There are dozens of forms that limestones can take, often making it visually difficult to identify. However, since limestones is made of the mineral calcite, it will bubble freely when strongly hydrochloric acid is applied to it. Limestone varies from light gray or brown to dark gray or brown. Shale, sandstone, conglomerate. Metamorphic rocks. Metamorphic rocks are created by the physical or chemical alteration by heat and pressure of an existing igneous or sedimentary material into denser form. Due to the action of plate, tectonics, compression, stress, and shearing forces over long periods of time, rocks can be essentially wrapped and deformed, causing them to be compacted into a smaller volume of space. As a consequence, metamorphic rocks are always more dense than their original material, and also much less susceptible to erosional breakdowns. As the Earth's plates move over geologic time, a plate containing igneous or sedimentary rock may become subducted under another plate. The sheer weight of the material above it can cause the rock to undergo metamorphism. In some cases, heat from the Earth's interior can melt the rock slightly in a process termed contact metamorphism. Examples of metamorphic rocks are schist, converted basalt, quartzite, compressed sandstone, and marble, compressed limestone or dolomite. Shown here is a sample of gneiss, the product of metamorphosed granite. Foliated metamorphic rocks. Common foliated metamorphic rocks are slate, phyllite, schist, and gneiss. Slate is a fine-grained, dense, and brittle, and is a metamorphosed form of shale. Slate can be seen west of Patters Spring in the Pilot Range, Box Elder Country. Phyllite. Phyllite is similar to slate but has a satin-like sheen on its foliation planes. Phyllite can be seen on the north and south flanks of Grizzly Peak east of Willard, Box Elder County. Schist. Schist has the same satin-like sheen as phyllite but has a coarse texture due to its high mica, muscovite or biotite content. The Little Willow Formation is a schist that is visible on the north side of the mouth of a little cottonwood canyon, Salt Lake County. Gneiss. Gneiss is a high-grade, high heat and pressure metamorphic rock in which the foliation results from a layering of different mineral groups, which give this rock a banded look of dark mica, amphibole, and other iron-magnesium minerals, and light, quartz, and feldspar minerals. Good examples of gneiss are visible in the Farmington Canyon complex in Farmington Canyon and at Frey Peak on Antelope Island, both in Davis County. Non-foliated metamorphic rocks. Common non-foliated metamorphic rocks are quartzite and marble. Quartzite. Quartzite is typically a metamorphosed form of sandstone. Unweathered quartzite has a sugary-looking surface. Individual quartz grains are deformed, interlocked, and fused together. When the rock breaks, it typically breaks through the grains. Some quartzite formations retain their original bedded, layered structures such that when broken, they form flagstones that commonly used in landscaping or as veneer for buildings. Quartzite is quarried from the Raft River and Grouse Mountains for use as building stone. It can also be seen at Strom Mountain in Big Cottonwood Canyon, Salt Lake County. Marble. Marble is metamorphosed limestone. The calcite crystals in marble are large and interlocking, forming a dense crystalline rock. Marble of the desert limestone and Gardison Formation can be seen in Big Cottonwood Canyon, Salt Lake County. Marble, slate, quartzite. Underground natural resources. Some rocks contain metallic and some contain non-metallic minerals. They are called ores. Examples: hematite, bauxite, pyrite, and calamine. These metals are used to make utensils, machines, furniture, wires, coins, rails, aeroplanes, etc. Coal and petroleum. Uses of coal. It is a black in colored solid used in railway engines as fuel in the olden days. It is used in thermal power production. Coal is the largest source of fuel used to generate electricity worldwide. Coal is used in manufacturing industries for heat and power applications. Coal is used to make steam for heating. It is also used as coke in steel making. Petroleum. Crude oil is used to make petroleum, a fossil fuel that is extremely important in our everyday lives. It ensures that we are able to get to the office and shops without having to resort to walking. This fuel also ensures that we are able to purchase food for our families that has been delivered to the store. In short, if the petroleum supply had to cease, the world as we know it would literally come to a complete stop. Uses of petroleum. Petroleum makes the world go round. Petroleum is instrumental in saving lives. Food supplies rely on petroleum products. Many consumers' products contain petroleum products. Conservation of natural resources. Conservation is achieved through measures adopted in favor of a natural resource in order to increase its longevity and improve usage patterns. Some such measures are as follows. Rational use of the resources. Rational use of the resources is one of the concepts in conservation of natural resources in an essentially undisturbed condition because they are of scientific interest, have aesthetic appeal, or have recreational value. Preservation also serves an ecological purpose by maintaining the function of the total environment. For example, protection of forests assures a sustained yield of water into urban reservoirs, and protection of estuaries perpetuate ocean fishery. But rational use is not just preservation. It also implies the direct use of resources for their commodity or recreation. Thus, harvesting of forest crops, livestock grazing of Greenland, catching fish and hunting wild animals can be considered a legitimate part of the rational use of natural resources, if they are carried out in such a way that the resource is perpetuated and not endangered. Sustained yield. Concept of sustained yield is involved in these activities. This means cropping the annual surplus of individuals so as not to endanger the breeding stock of game animals or fish. Similarly, tree cutting or grazing of grass should remove only the annual increment and no more. Restoration. Restoration is another important aspect of conservation. It is a widely familiar conservation measure, which is essentially the correction of past careless activities that have impaired the productivity of the resource base. Deforest areas, unmined and barren lands can be revegetated with some effort. Depleted animal and plant populations can recover if they are accorded protection. This measure is familiar in modern soil and water conservation practices applied to agricultural land. Restoration is possible, however, only as long as species are protected and genetic diversity of life is maintained. When species become extinct, the restoration of past conditions becomes impossible. Protection. Protection of natural resources from commercial exploitation to prolong their use of recreation, watershed protection, and scientific study. This is the concept underlying the establishment and protection of parks and reserves of many kinds. Reutilization. Reutilization is the reuse of waste materials, as in the use of industrial water after it has been purified and cooled. The same process becomes recycling if the water material requires minor treatment before it can be used, as in the use of scrap iron in steel manufacture. Substitution. Substitution, an important conservation measure, has two aspects: the use of a renewable rather than a non-renewable resource when conditions permit. Allocation. Allocation concerns the strategy of the best use of a resource. For many resources and their products, the market price decides as to the use a resource is put. But under certain instances, general welfare may dictate otherwise. The allocation of resources may be controlled by government through the use of quotas, rationing, and outright permits. Integration and resource management is a conservation measure because it maximizes over a period of time the sum of goods and services that can be had from a resource or a resource complex such as river valley. This is preferable to maximize certain benefits from a single resource at the expense of other benefits or other resources. Integration is a central objective of planning.